This is showing aerosols. Now, those are tiny little particles in the atmosphere. You see the movement of air masses and aerosols between continents. You see the formation of weather patterns. You see how these kinds of sources like fires are changing over time and influencing the air that we all breathe. One of the most direct things that we care about is their impact on human health. So certain types of aerosols are very damaging for human health, for people's ability to breathe. Scientists and researchers will use models like this to understand the risk for different populations and prepare communities around the world for meeting the challenges of changes in air quality. Another important aspect of aerosols is their influence on thunderstorms and rainfall patterns. Their presence can affect the intensity of storms and the formation of different types of weather phenomenon. So what you're seeing in this visualization is these tiny aerosol particles that are actually color-coded by the type of aerosol in the atmosphere. So in this visualization, the green is sulfate aerosol that comes from things like power plants, volcanoes. The reddish color is carbon aerosols. Those come from a lot of different fires around the world. The purpley color is actually dust that comes from most notably the Sahara and lots of other deserts around the world. And that blue color is sea salt aerosol that's coming from ocean spray. NASA's developed some of the most complex, detailed aerosol models in the world. And this is really important. Satellites let us see the total amount of aerosols, but they can't always tell us in great detail where that aerosol came from. Visualizations like this really help us understand intuitively how those aerosols might have gotten to a place that's different from where they were emitted. We actually had a colleague in Australia write to us about a previous visualization and say, I actually never knew how this air mass got to Australia, and because I saw this in a movie, I understood that this air mass had been lofted by thunderstorms in the mid-latitudes and actually transported by high winds at a higher altitude. So there's all kinds of things that we learn when we actually pair the power of visualizations, the power of what we can see, with all of the science behind the models that go into this. You also see this interplay of all of the different kinds of science we do, of vegetation, of fires, of weather patterns, of atmospheric chemistry. That's the beautiful complexity of all of the things that we do at NASA, and why it's really important to have this innovation across observations, modeling, computing, and visualization to bring this all together so that we can use it and share it with everybody who's watching this today.